Bismillahirrahmanirrahim. I'm intent on recording this today, inshallah, although I'm a little tired and I have this cough, which I do good part of the winter. Nevertheless, today I'd like to talk about the remainder theorem, inshallah. Which is quite easy, actually, which material that we already know, okay? But we're going to put it in a more formal algebraic fashion, okay? There's some terms that we first need to understand, okay? So when you're dividing 5 by 2, for example, this is 2.5, right? Which is 2 plus 1 over 2, right? So this is what you're dividing, and this is the divisor, this is the quotient, this is the remainder, and this is the divisor, okay? So the same happens when we are doing dividing polynomials, right? So, for example, if you divide this polynomial, either long division or synthetic substitution, whichever way you do this, so 5x squared minus 7x plus 2, and if you divide this polynomial by x minus 2, okay, the resultant is x squared plus 7x plus 7, and the remainder is 16 and over x minus 2. Okay, so now there's some terminology here. Okay, so this analogy is similar to what I just said. 5 divided by 2 equals 2 plus the remainder is 1 over 2. Okay, so right now, the terminology that we need to know is this. Okay, when a function is being divided by a certain divisor, okay, the resultant is, okay, the quotient, that's q of x, that's this over here, okay, plus the remainder, which in polynomial function is going to be a number or another polynomial, r of x, over the original divisor, d of x. Okay, so the terminology that we first need to appreciate is, let me just get rid of this. Okay, now that's the function. So this is just the function, and this is the divisor. Okay, that's the quotient. Okay, and this is the remainder. Okay, so when a function is divided like this, when we talk about this, this would be called the divisor. This would be the quotient right there. That's the remainder, and that's the divisor. Okay, and that's the original polynomial function that you were dividing. Okay, so that you have to understand. Okay, now what is the remainder theorem? The remainder theorem talks about this. Of course, it talks about the remainder. Okay, what it says is if a polynomial, okay, f of x is divided by a certain x minus k, okay, a binomial like this, which we have done before, okay, then you're going to have a quotient like this, okay, and then you're going to have a remainder, and the remainder is going to be f of k, okay, over the original divisor, which was x minus k. Oh, that sounds very fancy, right? Okay, this is actually the remainder theorem. So what it says is that it was when a polynomial, okay, or a function is divided by a binomial like this, okay, the remainder is going to be this, f of k. Now we know this already, actually. For example, if we have done this example before, I believe, f of x equals 2x cubed. I hope you're paying attention, because I know I'm a little tired. I'm not making this particularly exciting, but just pay attention, okay? So 2x cubed plus x squared minus 8x, okay, plus 5, okay? And if you want to divide this, and we have done this when we learned synthetic substitution, and we're supposed to divide this by d of x is x plus 3. If you recall, the way we did this is we copied down the coefficients and the constant like this, and we did one of these, okay, and then we put over here, if you recall, negative 3, not 3, right? Negative 3, correct? Okay, then we did the syntactic substitution. We did 2 goes over here, that's negative 6, that's negative 5, that's positive 15, and that's 7, that's negative 21, and then you get negative 16 over here. Okay, so if you recall, if you want to divide this, you did over here. Okay, now then we said, okay, this is going to be the remainder. Okay, so that's going to be the remainder, and that's going to be the quotient. Okay, so that's going to be the quotient. So this, and we wrote this when you divide this by this. Okay, so when 2x cubed plus x squared minus 8x plus 5 is divided by x plus 3, the resultant answer is going to be the quotient, which is this here, 2x squared minus 5x plus 7, and the remainder is going to be negative 16 over the quotient, which is x plus 3, like this. Okay, now if you look at this, okay, so this is f of x divided by a certain divisor, d of x. The resultant is a quotient, q of x, plus, now this is the remainder. Okay, so negative 16 is just the remainder of what? Okay, the remainder of f of k. Now, I didn't write this properly. When the divisor x minus k, okay, is divided by x minus k, then you have a quotient plus the remainder is going to be the remainder is going to be f of k, like this, over the divisor, which is x minus k. So this is the remainder theorem. It's just a fancy way of doing all of this that we have previously done. Okay, it says basically that when a function is divided by this, in this case it's positive, it makes it trickier, by a divisor, x minus this, then the resultant is a quotient, and the remainder is going to be f of k, f of negative 3. In this case, the remainder is f of negative 3 is negative 16, and that is the remainder. So remainder theorem basically tells us what the remainder is going to be. Okay, the remainder is going to be, if you're dividing by x minus k, the remainder is going to be f of k. Again, the remainder theorem tells us what the remainder is going to be. If you're dividing by x minus k, that's the divisor, okay. If you're dividing by x minus k, okay, like this, the remainder is going to be f of k. That's all that means, okay, f of k. And you should get rid of that properly. So this is the correct way of writing this. Sorry about that. So lastly again, the remainder theorem tells us what the remainder is going to be. If a function is divided by x minus k, the remainder is f of k. And that's kind of like all of the stuff that we intuitively already knew, but you got to know it as a remainder theorem. Why? Because one, it's going to be on the test, and secondly, it's good to know the formal nature of things and why we do things the way we do. Until next time then, assalatu wassalamu ala rasulillah wa alaikum.